Hello everyone. In the last session we have seen about the circuit theory and we have seen the different parallel combinations, series combination of capacitor and also the different combination of capacitor, how to save the states and how to save the amount and how to save the fabrication process and make it more easier. We have seen the combination and we have to start calculating the C equivalent for that combinations, and we have also seen one more thing that we can calculate a charge also. For that we have understand a very important concept, and this is final definition of charge, or you can say capacitance, because I have told you that as we proceed, or you can say proceed or move in the chapter, we will modify the definition of capacitance, and this is now the final definition we have concluded. And we have seen this thing, we can also calculate the charge also on the inner surface. So these all things we have seen, and I have also given you the homework to do the charge calculation for the inner surface for all these three combinations which we have done. I hope you have solved it. Okay. So let us proceed our discussion. Okay, further. So till here we have discussed about the different concept. Now the next one more important concept is that switching problems. Okay, that is switching problems. What type of problems? Switching problems. Let us talk about what is switching problems and how to solve the questions on this. Okay, if suppose the questions are coming on this, then how we have to deal with this type of question, that is switching problem. Let us discuss. Clear? Let us start our discussion with a one previous year question. Okay, let us start our discussion with a one previous year question. This is a previous year question. What they have asked? They have asked the charge flow or the charge on the capacitor. Charge, basically what they have asked, the charge flown in the branch 1, 2, 3 after the switch is closed. After switch is closed. Clear? This is the thing they have. So let us see the question first. What is that? What is the thing they have given? They have shown that they have shown a one battery of 8 volt, and then they have connected a one more battery of 4 volt. They connected this with a capacitor of 6 microfarad. Okay, and then we have connected this. This is the switch. This is the initial condition they have given, and then what they have told basically, I am closing this switch. After the closing the switch, what is the current in branch 1, branch 2 and branch 3? These are the three branches they have given. Okay, and they ask you the current in charge. Always I am seeing current, but that is charge. Okay, clear? So they ask you what is a charge flown through these branches. That is a question. Clear? Now the thing is that whenever any type of question which is given on the switch, what you have to do simply in the capacitor, let me tell you very simply. First, solve the circuit at whatever the condition is given, whether it is switch is open or closed. First, solve the circuit at that condition. Then after that, take it to the final condition which is given in has been asked in the question. Take it to that condition and again solve the circuit, again solve it. Okay, after this analyze the circuit. That is a step you have to follow. So what are the steps? This is a general steps which you have to follow. What you have to do? First, solve for the given condition. First solve the given circuit. First solve the given circuit. Then step 2, solve it for the first solve the given circuit, then solve it for the condition which is told in the question. Condition given in the question. Whatever the condition, they will give you some condition in the question, just solve it for that condition. Clear? And the last step is analyze the two circuit. Analyze the results. And I know you are not able to understand the steps, but as I will apply on this, you will understand it. Okay, so let us see. See, if you see what is the initial circuit we have. So initially solution, I am writing the solution for that question. See, initially what they have told, they have initially the switch will be open. Clear? Because they are asking after the switch is closed what is going to be happen. So initially the switch is closed, open. Okay, initially it is given the switch is open. Switch is open. Initially that is given. See, I am telling you each and every step. Only the reason is that you understand everything. That is why I am telling you each and every step. So listen very properly. What you have to do, first switch is open. That is the initial condition. So let's draw the circuit for that. This is 8 volt and this is 4 volt, I think so. Correct? Then we have a one capacitor here, one capacitor here, and the switch is open, means there is no connection. What is this capacitance value? This is 6 microfarad and this value is 3 microfarad. So for this, can you solve this? Yes, it's very easy. Okay, I can solve it. Simply, how to solve this? Very simple. You can take it as 0. You can take this point as 0. Take this point 0. 0. This will be this will be 0, this will be 0, this will be 4, this will be 12, this will be 12. Now they both are connected in series, so this will become 2. Correct? Series means 2. So what is the charge flown then? 2 into 12, that is 24 coulomb, microcoulomb. The charge flown is 24 microcoulomb. Charge flown is 24. Sorry. 1 minute. Charge flown is 24 microcoulomb, like this. Clear? This is the initially. Now this is the first step we have completed. Now what is the second step? What is the given condition? Now the switch is closed. The condition they have given is now switch is closed. So let us solve it for the condition when the switch is closed. Now for that condition, let me solve this. Okay, let me solve this for that condition. So for that condition, if you want to solve, what you have to do, just draw the circuit first. Let me draw it. One minute. We can do one thing. Not able to. Let me draw only. This is now the circuit will become this 4 volt, this 3 microfarad, this 5 microfarad, this 8 volt, like this. It is given. Now we have to solve. Now the question is how to solve this. Like what is the approach to solve this? The first approach will be, see, you have to take this at 0. Correct? So this will be also at 0. This will be 4 volt. Okay, sir. This is 4, so this will be also 4. This will be 12, sir. Correct? This will be also 12, sir. Okay, no issue. So what is the charge flown from here to here, sir? 12 minus 4 is 8. 8 into 6, that is 48 microcoulomb, sir. Okay. What is the charge flown from here to here, higher to lower potential, sir? 4 into 3, that is 12, sir. 12 microcoulomb, sir. So now you can see 48 microcoulomb is coming from here. But in this branch, we are getting only 12 microcoulomb. So some charge must flow in this branch, correct? How much charge will be flowed? 48 minus 12, that is how much? How much 48 minus 12? That is how much? 30? How much? Array, 48 minus 12. 8 minus 4 is 4 and 4 minus 2 is 2. So 24. How much it will be? It will be 24 microcoulomb and this is 12 microcoulomb. So now you see properly from here in this branch what is the charge? 24. Now it is 48, correct? So what is the charge flown in first branch? Now analyze the circuit. So this is the second step we have did. This is the second step we have did. Now we are going to do the first step. Now analyze. Now third step is to analyze. Now analyze the circuit. Now whatever you have solved, just analyze it. So once you analyze, you will see here initially it is 24, now it is 48. So how much charge in flow from here to here? How much charge in flow? Final minus initial. So from 48 minus 24, if you will do, you will get how much? You will get 24 microcoulomb, correct? So this is from path 1. Now from path 2, finally it is 24, initially it is 0, so it will be 24 microcoulomb. Now third branch, what is the current? Charge. Initially it is 24, now it is 12. Initially it is 24, now it is 12. So how much charge is flow? That is 12 microcoulomb. Yes, so this is the way to solve. So always what you have to do, first you have to analyze the circuit, initial condition, then final condition, and then just solve these two circuit and then analyze it simply. That is a simple thing you have to do here. Okay, not any big task you have to do. Simply you have to just do the analysis. Just do the simple analysis. Nothing else is required here. Okay, clear? Any doubt? Okay, so let me take one example so that it will be more clear to you. Okay, so let the example will be, suppose capacitor is 1 microfarad. Okay, I connected it to a 4 volt of battery, and here we have a 2 volt of battery, correct? But there is a something catch is there. The catch is like this. Okay, we are going from position A to position B. When the switch is going from, try to understand, the switch is moving from position A to position B. Okay, like that. So you have to calculate the Q flow in 1 microfarad capacitor. How much is the charge flow? Very simple question. Nothing difficult is there. How much is the charge flow? That is a question in this. You have to calculate. Okay. Till then you are doing this calculation. Let me write one more question. Or I can ask one more thing. Okay. Suppose this is 2 microfarad. We have 1 microfarad volt. Oh, okay, so that means initially it is open, now it is going close. My question is, what is my question? Heat loss in this case. Now you have to calculate what is heat loss in this. This is also a homework question. This is a homework question for you. If you are able to solve it, it's very good. Someone is able to solve this question, that means he is able to understand the whatever the concept I have told him. Okay, that is a very easy thing. Just note down for this homework. It's a very good question. Okay, so how you have to solve? First, what you will do? You will take first step. See, always do that in say step what I told you. First step. First, you will put the switch at A position. Then this whether this is required, no. So I will directly draw like this, because this will be 1 microfarad, correct? And so this will be my 4 volt. So obviously, so the charge flow will be, how much is the charge flow? The charge flow will be, sir, 4 microcoulomb, correct? Now this is the first step. Second step will be, what will going to be happen in the second step? Then in the second step it is very simple. We are going to connect here. This connection won't be here, so it will be something like this, sir. This is 1 microfarad, and we are connecting it with a, sorry, this is 4 volt, this is 2 volt. So this will become how much? If you take 0, this is 2, that is 6. So from here, how much charge in flow? The charge flown will be 6 microcoulomb. That is the charge flow. So from here to here, how much charge flown is in 1 microfarad? So the answer will be, what is the answer? 6 minus 4, that is 2 microcoulomb. Answer. Clear? So from here to here, how much charge has been flown through the capacitor? That is 2 microcoulomb. Clear? This you have to do the calculation, and you have to tell me the, initially it is at here, now it is at this position. Okay, that is a question. You have to tell me the heat loss. First, what you will do, you will solve it at open condition, then you will solve it at closed condition, and after that, and calculate the initial energy at any initial condition, calculate the final energy at final condition, and then calculate the work done by the battery, and then after that you apply the formula, work done by the battery minus final energy minus initial energy, that will give the heat loss for this. I told you the method. Now you have to solve and comment the answer in the comment section. Clear? Or in the group, WhatsApp group, wherever you want, you can tell me the answer. But this is a very good question. If you are able to solve it, then it's very good. It's a challenge question for you. Okay, it's a challenge question. If you have understand my concepts, challenge question. Okay, a challenge question for you. If you have understand, you can easily solve it. Clear? Otherwise you won't solve. Clear? Any doubt till here? If anyone have a doubt, please raise your hand. Please tell me if anyone have a doubt. No doubt? Okay. Completed? Okay. Okay, note it down. Note this. Note this question for this, for your solving. And what about the previous challenge question? I didn't see anyone have comment till now. No one has commented the answer for this question. Okay, you are able to calculate the heat loss for this. Completed? Okay. Yeah. So from here now, if you have remember, we have discussed that how the capacitor is going to be charged. That is a complete discussion we have did. If you are able to remember it, we have did the complete discussion in our one of the session. Yeah. This is the complete discussion we have seen. And we have seen the initial state, and we have also seen the final state. Clear? Only one state has been left. What is that stage? That is called as a transient state, that we haven't analyzed till now. Till now we haven't analyzed the transient state. Now what we are going to do, we are going to do the analysis of the transient state. and we will analyze that how the transient state behavior of a capacitor look like, how exactly the capacitor is going to be charged, and what is going to be the equation for the charging. That is going to be analyzed in this session, okay, or in this part. So our next topic will be the transient, that is called as a transient response of the capacitor, but the people used to teach it like a charging of a capacitor and discharging of a capacitor. So we will also discuss like that only, because that is a more familiar to you. So let us start with the first case, that is a charging of a capacitor. Charging of capacitor. Clear? And what is the thing we are going to see? We are going to see the transient response. Remember, the transient time. We are going to analyze the circuit in transient. Okay, that is a transient thing. Means it is still charging. It haven't charged completely. We haven't reached the steady state. Okay, we haven't reached the steady state. Remember my words. We haven't reached the steady state. Okay, so let us see. Start this and discussion. So basically in transient state, what is going to be happen? Let us analyze. See, suppose we have, obviously we have a resistor in this state, okay, and suppose it is charged to some charge small q, and it is connected to a battery of voltage B. Clear? This all things are given. This is 0, this is V, and this will be V. Obviously this will be how much? It will be 0, correct? So sorry, let me correct this, plus minus, okay. So this potential will be Q by C. Current will go like this. So I can write my current is equal to, sir, nothing but V minus Q by C divided by how much? R, correct? So I can say, sir, my I is equal to V minus CB by RC, correct? So from here I can write it as, sir, my what is I? I is defined as, we know I is equal to dq by dt. No, this is I, correct? So here if I apply this thing, dq by dt is equal to EV minus Q by RC. So let us suppose this is my equation number 1. So we have dq by V minus Q, sorry, V minus Q is equal to, that is dt by RC. Now you have to integrate. So at initial time t equal to 0, we are going to some time t. So at initial time t equal to 0, what is the charge? 0, because initially we are considering there is no charge on the capacitor. That all things we have discussed in the initially also. Okay, now at some time t, suppose the charge, basically what we want to calculate the charge at a function of some time. So at some time, suppose the charge is q of t. So when you now when you do this integration, remember the integration of, let me tell you, the integration of 1 upon x minus, or you can say integration of b minus ax, okay, into dx. For NEET student, I am telling this integration will be minus 1 upon a into ln b minus ax, correct? This is the integration for this. You just remember this thing. That is a very important for you, for the NEET student, because math J student, I think you know this formula, but I am telling for you also, because there are a lot of students in JEE also who don't know about this integration. Okay, so yeah, if you do this, what you will get? You will get, sir, I'm writing directly, okay, ln CV minus Q, correct, divided by CV is equal to minus T by RC. So from here you will get Q of t is equal to CV into 1 minus e to the power minus t by RC. That is the equation of charge. That is the equation of charge. If you analyze this equation, let me take it to the next page. So what is the equation we are getting? We are getting the equation as Q of t, okay, that is equal to CV into 1 minus e to the power minus t by RC. Okay, that is the equation we are getting. Clear? Basically what we know at, let's take time t equal to 0. At time t equal to 0, can you tell me what is the charge? Basically we know at initial time the capacitor is not charged, so initially the charge should be 0. So let's put t equal to 0 here, t equal to 0 here, this will become 1. So what is the charge you are getting? Q of t you are getting as 0. That means it is correct. Now similarly, put t is equal to infinity. If you put t equal to infinity, means steady state. This is what? This is the initial state. This is the initial state. What we have no. Okay, that we have, that is the initial state. Okay. Now put t equal to infinity. If you put t equal to infinity, this term will become 0. This term will become 0. So what is my Q of t? Q of t is equal to C into V. Okay, and that is the steady state. Steady state. So so by this I can say, sir, I can write my equation is equal to Q of t is equal to Q max. That is a maximum charge. Okay, Q max into 1 minus e to the power t by RC, where what is Q max? That we have seen, that is charge in steady state. And how to calculate the charge in steady state, we have seen the example. Okay, charge in steady state, because I have taught you that thing earlier only. Steady state. So if someone asks you to draw the graph, can you draw the graph? Yes, no problem. If you know the equation, there is no problem in drawing the graph. We can draw the graph, sir, no issue. No issue for us. We can draw the graph because you are my student. Sure, you my student, you can draw anything. There is no problem for you, because you are my student, and if you are following me, your all concepts will be very crystal clear. You will have a reason for everything. Okay, because in physics there is a reason for everything. In science there is a reason for everything. There is nothing called exception. Nothing is there. This type of things won't exist. Those who don't know, they will say it is an exception. Okay, if you see Q by t, Q of t versus time, you will see that at initially the charge is 0, and at steady state the charge is reaches to infinity. Like at some steady state, when the time reaches to infinity, the capacitor is going to be the maximum charge, that is Q max. Now there is something called as a, in this equation you can see something is called as a RC. What is the unit of this? What is the unit of RC? RC is defined as tau, which is called as a, tau is called as a time constant. Okay, this is called as a time constant. Okay, what is the significance of this? It tells us about the charging. It tells us about the rate of charging. Charging means if tau is large, suppose tau increase, then rate of charging will decrease. Means the capacitor will charge slowly. That is the thing. Rate of charging decreases, or vice versa. Clear? So this is the thing we have seen in the charging of capacitor. If someone asks you, okay sir, we know the current thing, no issue. If I ask you, sir, Okay, so this is the thing we got. Okay, no issue with this. This is a concept which you have to remember. Okay, that is a very important concept. Now the next thing is that, okay sir, that is a graph. Okay, so if now if my tau is equal to RC, then my Q is equal to how much? Q of t is equal to how much? That is Q max into 1 minus e to the power minus 1. That is defined as how much? Q max into e minus 1 divided by, can you tell me what is the value? What is e here? E is a coefficient of restitution. Huh? E is not a coefficient. E is mathematical term. It is 2.17, something like this. Put this value and you tell me what is Q max. What is this value? What is this value you are getting? What is this value you are getting? If you put here, what is the value you will get? Okay, 1 tau is defined as when my charge is become 0.637 of Q max, or some people used to say it is a 63.7%. Okay, like that. So that is the thing. Okay, now in the similarly, I hope it is clear for you. Are you able to understand the concepts? Basically, we are doing the PhD now. Okay, we have a problem. Now we are doing the PhD on that problem. That is called as a doing PhD on a problem. Okay, this is basically we are doing the PhD. Clear? These are two important concepts. Now suppose someone will ask you, someone will say you, sir, this is a graph for charge. Now can you tell me what is the equation for the current? Because current will also flow. Obviously current will also flow. So someone will ask you what is a current then? No problem. What we can say, see, we know that current is equal to, sir, I is equal to, sir, dq by dt. Correct? Okay. So just differentiate this thing. Clear? If you differentiate, I is equal to d of dt of, what is this, sir? This is q max, sir, 1 minus e to the power minus t by tau. Okay, t by tau. So if you differentiate this thing, what is the value you will get? You will get q max into, sorry, q max upon cr. Here, or tau, whatever you can say, q max upon cr into e to the power minus t by tau. That is defined as I of t, or you can write as v by r, that is e to the power minus t by tau. Or you can say this from here, if I put t equal to 0, what is my current? Current is v by r. If I put my t equal to infinity, what is my current? My current is equal to 0. So from here I can say my I of t is nothing but it is I max by t by tau. Now you tell me, when we get I max, what is I max? When we get a maximum current in the capacitor, this is a current at initial condition. At initial condition. And what do you mean by initial condition? When the capacitor is uncharged, that I have explained earlier only. We have discussed those things in the earlier sessions. Okay, lecture number, I think in lecture number 2 or 3 we have discussed that. Current at initial conditions. Okay, so that is defined as I max. So now if someone asks you to draw the graph for current also, can you draw the graph? Can you draw the graph or not? Are you able to draw the graph? I am asking, if you now know can you draw the graph for this? Answer is yes, sir, we can draw the graph, no issue. What do we have to do basically, sir? Now initially it is for current charge, now it is for current. Clear? So sir, this will become, sir, I of t, this will become, sir, t time, and initially the charge is, current is C. At t equal to 0 we have a maximum current, and now it is becoming 0 at infinity. So this is a I max, and if here you will calculate tau, 1 tau, this will become 0.37 I max. Okay, that is also called as a 37%. Okay, 37% of maximum value, 63.7% of maximum value. That is how we can draw the graph and do the different analysis if we want. Okay, clear? Now if in this same thing, see, I told you the equation of current and graph like that. If suppose, for remember this equation which I told you, this equation is valid for this circuit only. Okay, not for every RC circuit. For that RC circuit, that particular RC circuit, this equation is valid. And simply, if suppose if I ask you, can you tell me what is the graph for V of t? Can you calculate this? Yes, I know current, I know resistance, I can draw the graph V of t. Can you tell me what is a graph for P of t? Yes. Can you tell me what is a graph for C capacitance? No, C of t will be constant only. Heat, what is a graph for heat? H of t, like that. Anything I can ask, no issue. Okay, anything I can ask, because you know current, you know charge, you know everything. You can directly calculate each and everything. Okay, so if you have these two equations, you can write any equation for me. I can ask you any equation to calculate. If you have these two equations, you can tell me anything. Clear? Any doubt? Please note it down. One more thing you can, if you have observed, you can understand one more thing here. See, initially there is no charge, correct? At t equal to 0, if you see, the charge is also 0 and the current is maximum, means the charge is 0. So if at t equal to, one more thing you can observe, at t equal to 0, the charge is what? 0, and I is maximum, correct? So what is my initial energy? My initial energy is 0 for capacitor, correct? Capacitor, I'm talking about capacitor. Okay, now at t equal to infinity, the charge will become maximum, and what is the current? The current will become, sorry, I will become 0. So what is the final energy then? That is half into Q max square divided by C. So what is the heat loss? If I want to calculate, I have to calculate the work done by the, or you can say, if I want to calculate the heat loss, I have to calculate the work done by the battery. So initially the charge is 0, there is a no flow of charge. Now the charge has been, my final condition, the charge is Q max. So what is the work done by battery? The work done by the battery is defined as CV square minus this. So this will, you will get, but you try to understand the things, try to understand the thing. What I am trying to say here, that is, what is the work done by battery? First you tell me battery work done. Work done by battery. First you will tell me. See, the charge flown is Q max. Okay, Q max is what? Q max is C into V. So that is CV square, or you can write it as Q max into V. So you can see the half of, or so half of the energy is basically transferred to the what? Capacitor, and that we have seen in the earlier also. See, and where that half of the energy has been gone? The half of the energy has been gone to the resistor. The half of the energy has been gone to the resistor in the form of heat. Clear? So that is the thing we observed in the charging of capacitor. I hope everything is clear regarding the charging of capacitor. If you have a doubt, please let me know. Clear? Any doubt is there? Okay. Clear? Any doubt? So this is the charging of capacitor we have seen. Now the next topic is discharging of capacitor. Okay, what is the discharging of capacitor? So let us discuss about the discharging of capacitor in detail. Okay, uh, suppose there is a capacitor. Initially it is charged to a some potential V. Okay, that is plus minus. See there, initially it is charged. Now I have connected to a resistor. There is no battery, because why? Because initially it is charged only, na? So there is a no need of battery. So in this case, first basically what is going to be happen? See, on this surface we have a charge of plus Q and minus Q, correct? Now initially the what is going to be happen at some instant after some time t is equal to t seconds. What you will observe? You will observe that the capacitor is going to be discharged and the charge on this surface will become plus small plus q and minus plus q, correct? Charge is going to be decrease and the potential will also change. I'm not commenting about the potential. This is the resistance R is there and this is a capacitance C. So if I want to write the equation for this, what is the current in this branch? See, let us take the potential at this point is 0. This will be 0. What is the potential at this point? This will be Q by C. Correct? So current will flow like this. So I can say my current will be Q by C into R. Correct? Now what is I? I we know that is dQ by dt. Okay. Same as like what we have discussed for charging of capacitor. So from here, if you integrate same dQ by Q and dt by CR. Till here, anyone have a doubt or any mistake is there? Please let me know. First, tell me. Anyone have a doubt or any mistake is there till here? Please tell me. Any mistake? No? There is a mistake. Charge is increasing or decreasing? First you tell me. From here to here, charge is decreasing. So dq by dt is negative or positive? It is negative. So we have to put a minus sign to make a positive. That means minus sign should be also here. Are you getting my point? That is the thing. Okay. So if you integrate this thing, you will get what? Q by t is equal to same thing, same equation. You will get Q max into e to the power minus t by RC. Clear? Now, if you have this equation, similarly, if I can ask you what at t equal to 0. Let me ask you at t equal to 0, what is the charge? So you can tell me, sir, Q is equal to Q of t will be Q max only. And at t equal to infinity, sir, my Q of t will be equal to 0. Finally, it will become discharge. That is the equation we will get. So if I want to draw the graph also, we can draw the graph also, sir, no issue. My y-axis x, yeah, this will be my time t, sir, and this is my charge Q of t. Initially it is maximum charge and finally it is decreasing like this. This is my Q max. Q max is what? You know that thing. Okay. And this is defined as how much? Point how much? 37 of Q max or 37%. That is 1 tau. Tau is again here. Tau is what? Tau is what? Time constant. Unit is what? If I talk you what is the unit? Unit is second. Clear? Tau is equal to time constant and tau value is RC. Basically, I will tell you for this circuit. I am telling it's RC. Remember, whatever I am writing here, it is valid for this circuit only. Okay. Now, similarly, if I ask you what is my I of t, what you will do? So dq of t divided by dt. If you do this thing, what is the value you will get? Sir, we will get dq by dt is equal to, sir, nothing but I max into e to the power, sir, again e, this equation. If in this equation again, if you put t equal to 0, you will get my current is, what is my current? Current is equal to I max, and if t equal to infinity, you will put, what is my current? My current will be again 0. So that is the thing you will obtain. So if I ask you to draw the graph of current again, you can draw the graph without any problem, I hope, because the equations are same, so the graph will be also same. Okay, this is I of t, this time t second, so this is 1 tau, this point t7, I max. Clear? Any doubt? So everything is same. Clear? But can you observe one thing? In discharging, current is decreasing. Okay, understand. In charging also, if you will see, the current is again here also current is decreasing. In both the cases, whether it is charging, whether it is discharging, it doesn't matter. In both the cases, the current is going to decrease only. Whether it is charging, whether it is discharging, it doesn't matter. In both the cases, the current is going to decrease only. Clear? Okay. Any doubt? Clear? Okay. Now there are a lot of questions, and one more thing you can observe. For a charging a capacitor, how much time is required to charge a capacitor fully? How much time? Infinity. It is going up to infinity, correct? So how much time is required to charge a capacitor? That is infinity time. So that's why the questions you will get, they will ask you how much time it takes to charge a capacitor to 99% of its maximum value. Simple. What you have to put? You have to put my q is equal to 0.99. Simple. And you have to calculate the simple time. Okay, because this type of normal questions you will get. Okay, that is not a problem. Okay, because these are the simple questions only. They will directly give, if you remember these formulas, you can directly put and you can calculate. That is not a problem. The problem is, suppose if they will give you any circuit, see, this is a standard circuit. For this circuit we have solved and we have got the results. Okay, these are the standard circuit. For the discharging case also, we have taken a standard circuit, we have solved it and we have got the equation, got the results. The formulas is valid only when they are giving a standard circuit, but it is not always true that they will always give a standard circuit. They can give you any random circuit also. Then in that case, how will you write the equation? How will you calculate the current? How will you calculate the different values? That is the important part, and that we will discuss. Okay, that we will discuss. Before going to that, let me ask you a simple problem. Okay, it's a very famous problem. I hope most of you have seen this problem also. For both, Qmax is same only. Let me draw it properly. My drawing is not so much. Okay, let me. Okay, this is the one graph, and we have another graph also. Okay, this is my Qmax, this is Q of t, this is time t. Okay, question is, this is for R1 C1 pair, clear, and this is for R2 C2 pair. You have to comment on R1 C1 and R2 C2. The options are R1 is equal to R2, R1 is greater than R2, R1 is less than R2, none of above. And the second case in this is C1 is equal to C2, C1 is greater than C2, C1 is less than C2, C1, or you can take none of above. Okay, that you have to tell. Okay, let's tell me. I give you 30 seconds to solve this. Okay, use the 30 seconds and try to solve and tell me the answer. Okay, I hope you have solved it. See, first thing, if I ask you, this is a graph for charging or discharging? This is the graph for charging or discharging? Obviously, it is a graph for charging, sir. No issue. Yeah, because the charge is increasing. Okay, charging. For both the pairs, basically nothing is mentioned about the circuit now. So what you will treat? You will treat it as the standard circuit. If nothing is mentioned, you will treat it as a standard circuit. The standard circuit we know, sir. This is the circuit we have given. Okay, no issue, sir. So this is the two circuits are given for us. Okay. Basically, what is the thing? You can see for both the circuit, the Q max is same. What is the maximum Q max? What is Q max? Q max for both the circuit is same. Q max is same. So from there, what we can say? What is the Q max formula? That is C into V. So I can say C1 V1 is equal to C2 V2. And important thing is that they both are connected with the same potential. Okay, why? Because they are obviously if we are drawing a graph like this, that means the potential for both the, basically what you have to understand, circuit is something like this. Okay, means they both are connected with the same source. Okay, both are connected with the same source, means the circuit is like this. This is my C1, then we have a resistance R1. Okay, this is connected to a potential V. Similarly, we have another capacitor C2, another resistance R2, and this is also connected with a voltage V. That is the thing. Okay, that is the thing you have to understand. This is the thing which is given to you. Okay, so whenever you read the question, try to understand what is given, what is not given, then you will solve. So obviously we will get cancel out. So what is the value you will get? You will get C1 is equal to C2. So which option will be correct? First option will be. If for both the charge Q max is same, I can tell one thing. At 0.76 Q max will be also same, correct? Because if the Q max is same, 0.67 of Q max will be also same, correct? If this is same, for this it is tau 1, for this it is tau 2, correct? I can say from the graph, from graph, what I can say, sir, tau 2 is greater than tau 1. What is tau 2? Tau 2 we know, that is R2 into C2, that is greater than R1 into C1. C1 C2 is equal, so it is cancelled out. So R2 is greater than R1. Which option will be correct? R2 is greater than R1. Third option will be. Simple question. Okay, clear? So I hope you have enjoyed this session. We have learned a lot of new concepts in this. We have seen a very important topic, that is charging and discharging. And in the next session, we are going to learn that how for any given random circuit we can solve or we can write the direct equation, and this will cover the major part of our capacitor. Then we will move to the next part, that is called as a dielectric part, where we will discuss about the dielectric. Clear? And then we move to the variable capacitors and the force and other topics. Clear? So till then, if you take care, and if you have enjoyed this session, please like it, share it and subscribe it. Have a nice day. Thank you.